Yeah, so basically in Solidity, you have to declare all the types. I think it's the same. It's like that in TypeScript. I think it's the same in Java and some other languages. And the way that this works is that typically you call like the type is called before the actual variable name, and other languages it might be flipped. And here's an example, I believe Java might be similar syntax where this is creating like an array of unsigned integers and they're public. So let's just going through this like from left to right. Basically, unsigned integer is just the data type. Typically in Ethereum, the integer is using something called uint, which stands for like unsigned 256-bit integer, and that's kind of the standard like integer data type that people are using. And then public, which means kind of who can access and view this variable. So in Solidity, you I think it's four types of four types of I guess you can think of as like the scope of the variable. So public basically means that I can access this variable somewhere else in this contract. I can access it in a contract that inherits from this contract, which basically, like, if you're familiar with inheritance in Java, it's a similar type of idea. Or like if I say like I have a child contract, I can get all the methods from the parent contract. So I'd also be able to get this array. Also, any contract that's outside of my contract that calls it can also use this variable. So this variable is basically like open to anybody essentially in Ethereum, if that makes sense. That's what it means by public. There's some other types too that we will get into as we see them, but just to be aware, if you see something like public, that's kind of what it's referring to. So here we're just declaring an array. This is called a state variable, which basically means that it's stored in something called storage on Ethereum, which means that after, like, let's say I call a function in this contract from my own account or from another contract, and then that function executes, the variable, like this array, is going to persist. Meaning after I call it, like that array is still going to stay in storage on Ethereum and anybody can access it. And storage variables, so state variables, basically kind of interchangeable, are actually the most expensive variables to use. Sorry, somebody have a question? Okay. Yeah. So then and then the next one here is a mapping. So this is one of the other core kind of, I guess, like data, you call them like data types, data structures in Solidity. So this is similar to like a dictionary in Python or a hash map, where essentially uint, you're specifying kind of the type of the key and the type of the value, and then the name. So right here, you're creating essentially like a key value mapping between an integer and an address. So this is somebody's public address, it's a public key on Ethereum. This is called map. And then below that is called a struct, which is something I think you have in C++. And it's basically like, I guess it's like a mini kind of class where I think it's like a mini class and people basically use it to group like similar types of values. So let's say you want to have something like, I was trying to think of an example. Let's say you have a game, like smart contract for a game, you would have something called like struct player. And then in that struct, you could have something like uint name, uint, maybe like balance, uint something else, just kind of attributes related to one kind of common concept. That's a struct. Yeah. So here we have another mapping, and you can basically map from like something to something else, like anything arbitrary, except you can't map from a string to something, I believe, just because strings are not, it's just how like strings are presented in Solidity. It's kind of confusing. Like you're unable to do that just because of how the compiler works. Yeah, that's kind of in general some of these types. And then here's how you call functions or create functions. So some other languages, you have to write the name function, the name, and then again, you have kind of this parameter here. So here it says public, and this can be a variety of other options that we can discuss afterwards. But basically in Solidity, you have to explicitly say for like functions for variables, what, like, who can access it. And this is all in kind of this is all in this idea of basically making your contract as secure as possible by explicitly telling essentially like the compiler, but also yourself, who can access these variables. Because imagine you can make something like there could be some data that like you don't want you don't want anybody to access, like you only want the contract itself to access. It might be it might be like it might be like a balance or something, or like some it might be like amount of money or something that could be crucially, like if somebody had that variable and did something with it, then it could, drain somebody's funds. Like that's just an example. So that's why it's important to always know kind of the scope of all the variables you're declaring. So here we're just calling another function f. So it's similar to any other language. You just call it, write the function with the put the arguments in and have semicolon. So here what this is doing, we're calling this function f, which takes in the arguments. So this is an array of integers, and that's in storage. So storage is what I was talking about here above, which is basically this persistent like key value storage essentially on Ethereum that anybody can access at any time. And it's not wiped after the contract is finished executing. So here you have to say storage because you want to tell for function arguments, also you have to specify like where the variables are located. So this is in storage. We don't have to specify it's in storage here because by default, any variables essentially declared outside of a function are in storage, unless you tell Solidity otherwise. So that we see that also here with the same mapping. That's the mapping up here. That's in storage. And then the struct as well. Now we have here also in storage. So, and then here, basically, we see the keyword internal. So this is, I know it's kind of weird because it's on multiple lines, but this is the similar syntax of this, where you basically write the word function, name of the function, put the function arguments, and then after that, before you actually do kind of the beginning bracket to write the logic, you have to say what it's exposed to. So internal basically means that anyone in this contract called data locations and any contract that inherits from this contract is able to access it. So this was something that they specifically scoped. And there are two other ones. There's something called external and also another one called private. And those have similar functions, or like they have different functions, but it's a similar idea. So external means only a contract outside of this contract can call it. So typically people might do that for a method like withdrawal, where like you're not going to call, like a contract itself is not going to withdraw money from it itself, or like but only like a different contract could withdraw the funds. So that's an example. Private means it could be something sensitive, I think. Something sensitive, like something you don't want another contract to be able to access to and potentially change. So private variables are only within the contract itself. So as I was saying, we just call it here. That's kind of typical. And then here we are just like a normal kind of language. We're setting it into store. We're basically like setting a variable called myStruct of the struct, like myStruct. And then you're saying that equal essentially to one of the structs in this mapping. And it's kind of a bit of a mouthful, but this is just to show that you kind of this like general language programmability. And as I was saying, like here, because this variable right here is inside of a function, you have to mention where it's stored. So here you're saying it's stored in storage, which is that more expensive persistent storage. And then here you're just saying it's stored in memory. So you can think of memory as kind of like, memory is basically the space that the program uses to put like intermediate kind of variable values while it's running, but then it's wiped at the end. The thing though is that this is like typically you never want to use storage. Like I'm not sure, I think this is just to show you guys, but you would use memory here because storing a variable in memory is far cheaper because it's not being stored persistently on Ethereum. So you only want to store things in storage if you think that people need to access that variable at a later date after the contract has been called. So an example of that could be, so something we typically see is a mapping of like addresses to people's balances in whatever, like in your contract basically, or addresses to some other kind of important variable in your contract. So those are typically things you would want to store in storage because basically you would want at any time someone can call my contract, or someone can call your contract and figure out how much balance this particular account has in whatever like use case you have. So that's sort of one of the like main things you guys want to keep in mind is that you always want to be very stingy with the variables you declare in storage and the kind of like the state variables you declare, because the way that Ethereum works is that you have to pay gas for types of different types of code that are in your contracts, and code like having like the storing variables and storage or is costs a lot of gas just because it has to be stored on Ethereum indefinitely. And that not only makes it more expensive to deploy the contract to mainnet, but also when people use it and they have to change some variable inside they have to change some state inside your contract. If you're changing a variable, if like you're interacting with storage, it's going to be more expensive. So that you want to that's like one of the principal things you want to keep in mind. So you might hear people talk about like how to optimize smart contracts. This is kind of what they're referring to in general. There's some other like optimization we can get into later, but this is kind of one of the important like things to keep in mind. Cool. So these are just some other kind of functions in this contract. And basically, like the word for this is just kind of a function signature. So as we were saying, we can just walk through this. So the function is called G. And as a parameter, it's taking in an array of unsigned 256-bit integers. And these are stored in memory. So what that means is that, like, let's say we could call this function G from another function, where in that other function, we have this integer array stored in memory. So that's why we're specifying memory here. And this one's public, meaning anybody can access it. Any contract, including the contract itself and its children, can access it. And this is the return type. So this contract here and this contract here, we don't have any returns because it's not returning anything. When you have a function that returns something, you have to write returns and then essentially the type of what it's returning. So this will return another kind of like list of or array of integers in memory. That's just kind of like a basic, yeah. And then this one, as I mentioned, there are other functions, there are other like signatures. This one's external, which basically means that only external contracts can call it. Meaning like I can't call this function H from inside my contract. And you might see this thing called, so this says type call data. And what call data is basically like the inputs to your function if an external contract is calling your function. So the name is kind of, I mean, I think it's kind of confusing, but that's basically just what it kind of like basically what it means. Does anybody have any questions so far? I know it's kind of weird to look at this, and I might not be explaining it super well. I'd probably like go back to this later, but that should give people sort of like a general sense of how like contracts are constructed and kind of like the variables you have access to, and so like sort of like heuristics. But yeah, basically the syntax is pretty similar to what people might be used to, and it might be similar patterns of coding. It's just you have to just think of like when you're writing contracts, you basically want to think sort of about two things. So one is security. So which kind of comes down to who can access what functions, under what circumstance can they access these functions, and are there ways in which somebody could access this function that I'm not anticipating? And if you think about that clearly, partially through just going through the logic and testing it, but also through kind of choosing like the scope of your functions and also where your variables are stored, etc. That's kind of the first way to do it. And then the second thing is basically GOTS optimizations. So that really comes down to principally like how you're structuring your code, where you're storing variables, etc. You basically want to be as concise as possible, just like as a general tip, like when you're writing contracts. But there's also kind of a fine line between being super concise and also being confusing to read. Because if somebody doesn't know what's happening in your contract and use it and get some like loss of funds because they think a function is something, but it does something else, in my opinion, like that's a way worse issue than spending a couple more dollars on gas. So those are basically like the two principal things you guys want to keep in mind. Let's see. Okay. Go to this. Yeah, so I think today we'll just go through some of these different Solidity by example things and just get like a kind of a flavor of the syntax. So this is talking about view or pure functions, which are basically kind of more things you can add to your functions. So you can see like these function signatures can get really long in Solidity, which might look sort of annoying. But basically, like a view function, you just don't modify the state. And then a pure function means that you're not even touching the state. And the state again are basically like variables that are stored in memory, or excuse me, in storage. And basically the reason why you want to add these signatures like view and pure is that Solidity knows that like nobody's going to change the state, which makes the overall gas cheaper because it doesn't cost any gas to just view the state of a variable, but it does cost gas to change it. Yeah. So this is just talking about, so there's a concept of a constructor, which for people who've taken like some Java courses, similar type of thing that basically executes when you, in Java, it executes when you instantiate a class. Here, it basically executes when you first deploy the contract on mainnet, like first like initiate the contract. So you typically use constructors for like variables that you want to externally set. You don't want to hard code them into the contract, but you want them to be set forever in the contract that you deploy. So it's a similar type of thing. Where is it? Yeah, so similar type of thing like normal Java code basically, where we still have the same the type of it, where is it stored, and then just kind of what you're doing. So here basically this means like if we when we deploy this contract Y, when we're deploying it, you would pass into the constructor like this a string, basically a text, and then it's going to then set this state variable that's stored in the permanent storage text to that string. So as I mentioned, you basically want to use constructors to set state variables that you don't want to hard code, but you want to be the same value, and you want to basically you want to have the same value forever, or until you redeploy the contract. So now we're going to talk about kind of interfaces. So when I learned this in Java, I didn't really sort of understand it super well. But here it's kind of a similar thing where essentially like if you write a contract, you want somebody else to interact with your contract, you want to interact with somebody else's contract, you typically create something called an interface. And basically interface describes all the functions that are in your contract. So yeah, so it's essentially like the functions in your contract, but without the kind of logic inside of them. So we see variable, for example. So this is just a public variable, there's no function, but in this interface here, you're saying it's view because you just want to, if this is essentially, this is like a default function to view the state variable. So you declare that here, then increment here. We have, that's just taken from here. So we're just taking the signature on the top line without the logic inside. Basically what this does is that this allows, like, let's say I want to use Uniswap code, but I don't want to have to dig through the Uniswap contracts. You can get a sense of what each function returns and how to use them just from the interface. So here, and the way that you would do that is you almost like instantiate an interface like you would an object in Java. So here's an example where we're calling the interface iCounter, and we're basically initializing it with the address that this counter function lives at. So for people who are not familiar, the way that basically in Ethereum, you have like there's like a general concept of an address. So a user, like I have my Ethereum address, which is kind of a short to public key, and every single contract has an address. And that basically allows people to like see, it allows people to kind of like map and look at like contract code across the global kind of shared Ethereum state. So you pass the address of the specific counter contract into or whatever contract you're doing into the interface for that contract. And then from there, you're able to use the methods of the actual initial contract. So we see that here again. Address is another type that's built into Ethereum. So this can either be a contract address, as I mentioned, or like a personal, like somebody's address. Yeah, so this is just a less like trivial example with Uniswap, actually. So these are two interfaces. And if people are not familiar with Uniswap, it's basically the main decentralized exchange on Ethereum, or one of the most prominent ones. And it basically allows anyone to trustlessly swap one token for another using kind of this interesting mechanism of like constant, of basically like a constant product, like a constant ratio between the value of two tokens. So here's an example, just like a simplified interface of something part of the Uniswap V2 contract. So here's just called like get pair. And basically, as we can see from the function call or from the function signature here in the interface, this takes in two addresses of two tokens. It's external view, which basically means that this is meant to be called by another contract, and you're only able to view the state, and then you're just returning the address of kind of like what represents like the pair of those two tokens that people can trade against. And similar thing here, I don't have to read through it, but basically, yeah, similar idea. So here we're creating a couple addresses. So one for the factory, which corresponds to the contract for this Uniswap V2 factory interface, one for DAI, which is a ERC20 token, and one for wrapped ETH, which is kind of like the ERC20, which is like the token standard on Ethereum for all non-Ether tokens, basically. And then wrapped ETH is like ETH. It's like Ether, but in the ERC20 token standard. So when people use ETH in different like DeFi applications, like if I want to lend ETH on Compound, for example, you're actually using this wrapped ETH. So that allows like a general contract to be more generalizable beyond just taking in like the basic like ETH currency that's the base of Ethereum, but allows it to take in any arbitrary token that adheres to this like ERC20 generally agreed upon contract. So here, similar as above, we're just creating a variable called pair that's type address, where we're instantiating this Uniswap V2 factory interface with the address of factory, and then we're just calling one of its methods get pair, which we saw its signature here, and that pair is the DAI and the wrapped ETH. Then we're doing the same thing below and returning at the bottom. And forgot to mention, so I think it might be similar in other languages, but if you want to return multiple things from a function, you just have to put it in parentheses and write kind of what you're returning. And let's say you're calling a function that returns multiple things. It's the same thing, but let's say you only want the first two things that it returns and not the third, then you can just put a comma and have a blank space. And that's sort of how you can like only get the return thing, like this is how you can get only the things that you need from a function called return. And it's important to do this actually here. It might look kind of weird, like why not just get everything? But this is all in the name of being gas efficient and making sure that you're only declaring variables and only kind of getting the essential things you need to use in your contract. Yeah, I think it's probably a basic. Yeah. We'll just do like how to send Ether as the last thing, and then have a brief discussion if people have any questions. Yeah, so basically the way in Ethereum, there's a difference between like the native ETH currency and how you can send it via smart contract kind of programmatically and other tokens on Ethereum. So let's say like the Uniswap token Uni, for example. That's like an ERC20 type. And ERC20 is essentially a contract, like a basic contract that anybody can extend and change the parameters of. So basically you would do something like you would inherit from the ERC20 contract, then you can change the name of your token, set the max supply, do other things you want, and then that kind of contract for your token has set functions to interact with it. So one could be like transfer it to another person. So that's how you interact with any other token, like programmatically on Ethereum. We can kind of go into that contract next time because I think it's one of the like canonical important things to understand. But Ethereum actually has in Solidity, there's a lot of built-in functions to use with just to transfer Ether. So there are actually three. So one's called transfer, another one's called send, another one's called call. And people can go over this in their own time, but basically, like if you want to send Ether to a contract, that contract has to either have a function that's called receive, which can have no logic or whatever logic that you want. So basically, like you can create a receive function inside. You could write some code that says what to do with the ether that your contract receives. You have another one called fallback that's basically doesn't, it's kind of a similar type of thing. There's a slight difference between the two, which I'm not actually like 100% sure in the difference, but typically, yeah, but typically I think like receive is used more often. And then there's another one called, so call is the third one. So here it says not really to use transfer and send. And I think the reason why is because call is slightly low, it's like a slightly lower level call or like way to send ether and kind of like the most direct way to send it. While transfer and send might use some other methods to do it underneath. So kind of the way you would use call is, you can see it here. So I'll walk through it. So basically, let's say I have my account. I'm going to call this function send via call from my like personal account. And I'm going to input, I don't know, like David's address. So here you write address payable. And basically in Ethereum, whenever you're creating a function or you're writing a variable where you're going to send money to it, you have to add the signature payable, which basically tells Solidity that this address should be able to receive money. And this is another kind of safety check where you don't want to accidentally send money to somebody who can't receive it. And then this function is also called, yeah, and called payable also because you are using it to basically send money to somebody. So here, the way that call works is that this is the person I'm sending it to, and then you do dot call. And here inside the brackets is essentially the value you're passing. So in Ethereum, you have, or in Solidity, you have a couple of, I guess, like native ways to interact with your addresses and kind of like interact with addresses and accounts in Ethereum. So one is message.value. Basically, what that means is like Solidity and kind of the virtual machine is able to like know intrinsically how much money you're sending to somebody else. So it's kind of like a global variable that you don't have to declare, but that Ethereum will be able to map to your own address. So the way that the way that this would work is that I would call this function, send via call. I would then specify the amount of ETH I want to send, and this function will automatically pick it up, basically, and then send it to whoever it's sending to, and that just returns like boolean whether it works sent or not, and then some data. And underneath here, we haven't encountered this yet, but good practice kind of in Ethereum. It's almost like in other languages where you might have some assertions or checks to make sure everything's going properly, correctly. That's something you want to do over and over again in Solidity smart contracts, just in the name of safety, to make sure things are behaving as you want. So here, this is one example of that. So this is called a require statement. And basically the way it works is that like if the variable on the left is true, then keep going. But if it's false, then you'll basically print this like error message. And it'll kind of like publish this to Ethereum so everybody can know. Yeah, if people are curious, like there are sometimes to use these other functions, but I think they're just older ways to do it. And this is kind of like the current recommended thing. So I recommend just like really understanding what this exactly does. And they're more functional, like you might see this double quotes here. There's more functionality to it, but I don't really think we need to get into now. This is kind of like standard usage. Yeah. I think we can probably stop now, actually. And then yeah, next time I'd suggest like before next time people to go through this in some other maybe simple tutorials. So everybody's kind of on the same page and kind of like look at again and review what I just went over today is kind of like a higher level of how contracts work. And then the next time we should be able to look into actual in production contracts. But yeah, does anybody have any kind of questions or I guess like requests to what we should be focusing on in the beginning? I hope this was kind of remotely helpful. I know it might have been a bit quick. Oh, you're on mute. All right, I can't hear you.
Sorry, is that good?
Yeah, you're.
All right, awesome. We have a quick question. First, thanks. This was awesome. So my question is kind of how gas is spent as programs are executed. Like I know I can look on F gas station and see average Gwei, but is there somewhere I could see kind of average gas per different kind of function? You know, you talked about the difference between storage and memory. Just
Yeah.
how it work.
Yeah, so I think you may be able to use in hard hat directly, but if not, I think there's like a plugin to it where you can like when you're testing your contracts, you can see how much gas it's using. So you can actually like specific, yeah, you can get like specific readouts of that. So that's yeah, that's definitely kind of a good practice, I'd say.
Okay,
That's
awesome.
good sense. Yeah, are there any other questions? Yeah, actually, just quickly, I want to end with like opportunities basically for engineers, or at least no Solidity. So there's currently like the demand for engineers who can like who know Solidity and can make smart contracts is far, far higher than supply. So even though you might not be super experienced, like either as an intern out of college, people are willing to hire people, which is something like even though it might not seem like that kind of ostensibly, like there are not a lot of listings for like junior study engineers or interns, people are open to like if you reach out to them to take on people that you're in like a part-time or full-time capacity. That's I'd say the first thing. The second thing though is that the way people can contribute is on more like part-time ad hoc basis. So that could be through a lot of the crypto projects are open source, not just like the core protocols, but a lot of the applications and people welcome contributions. So a way you can get involved with that is that almost all these projects have their own discourse you can join and probably ask like what are some problems people need help with and start kind of working with the team that way, putting up like PRs on their GitHub, etc. It's a pretty fluid process. So there's definitely like a multitude of ways people get involved. Also, if you're interested in just working on like your own side projects, I mean, we give small grants at 1.5K, but also a lot of the bigger kind of projects in the space like Uniswap, Compound, etc., not just in the Ethereum ecosystem, have pretty big grant programs where if you're building a project that could perhaps like serve one of those communities, they'll give you a pretty decent amount of funding. It's kind of an annoying process, but like yeah, those are just some of the opportunities out there. And kind of yeah, and lastly, yeah, no, I think that's probably it. Cool. All right. Thanks, guys. Hope this was yeah kind of helpful.
Thank
Thanks,
you.
Alex.
Too.